the cumulative distribution function CDF of x is given by f of, so this is denoted by capital F, fx x. So, fx x, how we define actually? Fx x nothing but probability that x less than 2s. We have already known, we have already discussed that whenever probability density function is given, we can find the cumulative distribution function from this probability density function. So, this formula is nothing but minus infinity to plus x fx t dt. Now, this density function is 0. So, it is A, this is B, this is actually 0 whenever. So, whenever you are finding probability means you are finding area under this curve. Now, whenever x is less than A, so this is area under there is density is 0. So, then this will be equal to 0 whenever x is less than A, less than minus infinity. Now, whenever x is inside this interval A to B, then x is greater than equal to A, less than B, then we will do the integration. Suppose somewhere here x is here. So, then this area will be, so the minus infinity to x fx t dt. So, how we will find that? For x is greater than equal to A, less than B, this fx x will be nothing but minus infinity to x fx t dt, because it is 0 minus infinity to A, it is 0, it is nothing but A to x, this because it is 0 outside this range. So, this is nothing but 1 by b minus a, this value inside this interval is 1 by b minus a into dx. So, sorry dt. So, dt. So, then this is nothing but t, if you take this is 1 by b minus a, this t a to x, if you take the limit, this is x minus a by b minus a. So, this is nothing but x minus a by b minus a. Now, what will be whenever x is here? So, because x is here means you are doing integration over minus infinity to x. So, minus infinity to a, this integration is 0, there is no density. Now, a to b, because it is a density function. So, because we have solved this equation, then so using this b minus a, 1 by b minus a if you take, then this integration will be 1, it is a density function. So, that is why whole area is nothing but basically this is the height 1 by b minus a, this area is nothing but b minus a into b minus a, this will be 1. So, it will be 1 and plus this b to x, again no densities, this is 0. So, that is why this integration will be 1. So, the x greater than equal to any value less than infinity. So, if you do this analytically also, this is nothing but fx x, it is minus infinity to x fx t dt. So, because it is greater than b, you can divide it minus infinity to a fx t dt plus. So, let us do in the next slide. So, this is whenever x is greater than b less than infinity. So, then fx is nothing but minus infinity to x fx t dt. This is nothing but minus infinity to a fx t dt plus integration a to b fx t dt plus b to x, because x is greater than equal to b fx t dt. So, then this is 0. So, that is why 0, because this function is 0 in this, and here a to b, this is nothing but 1 by b minus a dt plus again this value is 0. So, then this integration will be 1 by b minus a, and this is t limit a to b. So, then this is nothing but b minus a by b minus a, this is equal to 1. So, that is why this density distribution function is looks like this. Now, if you draw this, if you want to draw this, you want to show graphically, this is suppose a to b, and then this distribution function, suppose if you want to show graphically. So, it is minus infinity to a, this is 0, and at b it is 1, suppose this is the 1. So, this is 1. Now, then this will be, so this will nothing but this is the, this will be this and then this. So, this is the f(x)(x). So, this is the curve actually nothing but x minus a by b minus a. So, this is f(x)(x) equal to x minus a into b minus a inside this interval a to b. So, this is the cumulative distribution function of a continuous random variable. Now, we will learn how to find the mean and variance of this continuous random variable. So, the mean mu1 dash will find expected values of x. This is nothing but by definition minus me to plus infinitive x f(x)(x) dx. So, how we can find that? So, because minus me to plus infinity it is not non-zero, outside this a to b it is 0. So, that is why x and f(x)(x) is nothing but 1 minus b minus a to b and dx. So, then this is nothing but 1 by b minus a, this is integration is x square by 2, this limit is a to b. So, this is nothing but b square minus a square by 2 into b minus a. So, now if you simplify these things, it is nothing but b minus a into b plus a by 2 into b minus a. So, this is cancelled, this is nothing but a plus b by 2. So, this is the mean of this random variable. Now, if you want to find the variance, so variance we know that sigma square x for a continuous random variable, this is expected values minus whole square. So, that we know that this simplification we use this simplified formula mu2 dash minus mu1 dash whole square. So, now this mu2 dash we have to find out. So, mu2 dash is nothing but expected values of x square. So, this by formula it is nothing but minus mu2 plus infinity f(x) square f(x)(x) dx. Again, since it is non-zero only a to b, so this is a to b x square and this value is b minus a dx. So, then this is nothing but 1 by b minus a x cube by 3 and then limit equal to limit we have to use, this is nothing but a to b. So, this is nothing but 1 by b minus a b cube minus a cube by 3. So, then we can solve it on, we can simplify it, it is nothing but b minus a b square plus ab plus a square by 3 into b minus a. So, this is cancelled. So, then we just find it expected values mu2 dash is nothing but expected values of x square, it is nothing but what we found b square plus ab plus a square, b square plus ab plus a square by b square plus ab plus a square by 3, because this b minus a is cancelled, b minus a is cancelled, b square plus ab plus a square by 3. Now, we want to find the variance. So, variance of x, so we denote by sigma square. So, this is nothing but mu2 dash minus mu1 dash whole square. So, this is nothing but b square plus ab plus a square by 3 minus mu1 dash, what is mu1 dash? A plus b by 2 whole square. So, then we just simplify these things. So, this is b square plus ab plus a square by 3 minus a plus b whole square, this is a square plus 2ab plus b square by 4. So, then just we just simplify this 12, this is 12 and then this is 4 b square plus 4ab plus 4 a square minus 3 a square minus 6 ab minus 3 b square. So, then we just what we got, this is nothing but b square minus 2ab plus a square by 12. So, this is nothing but b minus a whole square by 12. So, this is the variance of the uniform distribution. So, these are the some of the properties we found, that probability density function, cumulative density function, then cumulative distribution function and also mean and variances of this continuous random variable we found. So, what are the use of this random variable? This is the application. So, it represents a situation where all outcomes in a range are equally likely. So, we do not have any preference or any kind of more weightage we can give, like we do not know that some portion is more possibilities than the other. So, in that case we say that it is a uniform distribution. For example, position of a particular molecule in a room. So, position of a particular molecule, we do not know that any position is can be given in a favorable, we can favor it any position. So, that is why it is a uniform. So, all are same. The point on a car tire where the next puncture will occur. So, this is the car. So, where it will puncture, we do not know. So, then we will consider it is a uniform distribution. Similarly, distance from the origin after throwing a dart to target on a board, we are throwing a dart on the target, and the distance from the origin we do not know where it will land. It will be so if someone is specialist, then it may be very close to 0, then we can give more weightage close to 0, but in a random person, those we do not know, so anywhere it can land. So, then we say this, it will be a uniform distribution. So, let us do some numerical example that can be utilized to the concept of uniform distribution. Suppose let if x is uniform distributed with mean 1, if x is uniformly if x is uniformly distributed with mean 1 and variance 4 by 3, variance 4 by 3. Find probability of x less than 0. So, how we can do this, solve this problem? So, it is already given, it is uniform distributed. So, it will be uniformly distributed over a, we do not like this uniform distribution over a interval a b. So, a is less than b. So, a and b is not given. Instead of that, uniform distribution with mean 1 and variance 4 by 3. So, let x having uniform distribution over a interval a b, then we know that what is the expected value of x, mu 1 dash. This is nothing but, we have already computed this value is nothing but, this is mu 1 dash, it is a plus b by 2. So, mu 1 dash is nothing but a plus b by 2. So, now and also variance also we know that variance is nothing but b minus a whole square by 12. So, this is given, and variance sigma square x, this is variance of x, this is nothing but b minus a whole square by 12, b minus a whole square by 12, we found that. Now, according to this problem, if x is uniformly distributed with mean 1 and variance 4 by 3, so this mean 1 and variance is nothing but 4 by 3. So, two equation, two unknown. So, we got that a plus b is equal to 2, this is one equation, and another is that b minus a whole square by 12. So, 12 b, this is nothing but 4 into 12, so by 3. So, then this is nothing but 16. So, b minus a whole square is 16. So, b minus a can be square root of 16, it can be plus minus 4, but because you are considering a is less than b, so it is positive. So, it is nothing but root over of 16, we will consider as the positive 4. So, b minus a now found that it is 4. So, now this is equation 2. So, then now if you add, then we will get 2b is equal to 6 if you add equation 1 and 2. So, then we will get b is equal to 3. Now, if you put b is equal to 3 in one of the equation, so then you can find that b is equal to, from equation 1 implies b is equal to, a is equal to 2 minus b, a is equal to 2 minus b. So, 2 minus 3, so this is nothing but minus 1. So, what we found that x is uniformly distributed over a b, where a is equal to minus 1 and b is equal to 3. So, that is why b minus 1 it is coming 4. So, that is why two equations are satisfied. So, then find x is less than 0. So, how we can find that? So, this density function now we know f of x is equal to, because 1 by b minus a, 1 by 4, whenever x is greater than minus 1, or you can write less than, greater than equal to, less than equal to 3, and it is equal to 0 otherwise, 0 otherwise. So, then how we can find the probability of x less than 0? So, it is asked that what is the probability x is less than 0. So, probability that x is less than 0, this is nothing but minus infinity to 0 f(x)(x) f(x)(t) dt. So, then because it is non-zero inside this interval only, so this is nothing but minus 1 to 0 f(x)(t) is 1 by 4 this dx or dt. So, then this is nothing but 1 by 4 t, limit is minus 1 to 0. So, then this is 0 minus 1 is 1. So, this is nothing but 1 by 4. So, this probability that x is less than 0 is nothing but 1 by 4. So, this is one numerical problem we can use this uniform distribution. Now, so next we will discuss another problem. So, let us do one problem. So, based on this uniform distribution, subway trains on a certain line run every half hour between midnight and 6 in the morning. What is the probability? What is the probability that a man entering the station at random time during this period will have to wait at least 20 minutes. At least 20 minutes. So, at least 20 minutes. So, now since x is the random variable, so the problem it is given here, subway trains on a certain line run every half hour between midnight and 6 in the morning. What is the probability that a man is entering the station at random time during this period? So, now during this period, this person so entering, then any train can come because it is a half an hour, every half an hour it is coming. So, we do not know when it will come. So, that is why this kind of situation we do not know. So, that is why it is, because the duration is the half an hour. So, x be the random variable, let x be the random variable denote the random variable for the waiting time. For the train. Now, since under the assumption because it is half an hour, within half an hour it can come any time, so it is distributed. So, under the assumption x will be distributed uniform 0 to 30, because by half an hour any time it can come. So, it is a uniform distribution. So, now then the density function, the probability density function, we write PDF of x is given by f of x is nothing but 1 by 30 whenever x is 0 to 30, it is a is 0, b is 30 and it is 0 otherwise. So, this is the now question is that what is the time during this period, we will have to wait at least 20 minutes. So, then we have to find the probability that x will be greater than 20, x will be greater than 20, x is greater than 20. So, this probability is nothing but integration 20 to. So, now the upper limit is maximum 30, otherwise this density is 0, f x x dx. So, this is nothing but 20 to 30. Now, this is nothing but 1 by 30 dx. So, then this is nothing but 1 by 30 integration x, limit is 20 to 30. So, this is nothing but 10 by 30. So, this is nothing but 1 by 3. So, that is why the probability that the person has to wait at least 20 minutes for the train, it is nothing but 1 by 3. So, we just completed that one continuous distribution function, it is nothing but the uniform distribution. So, next we will discuss more distribution like continuous distribution, some of the important distribution, one of the that exponential distribution function, exponential distribution. So, random variable. So, we will discuss in the next we will discuss the exponential distribution. Now, we will discuss another important continuous distribution, it is called exponential distribution. A random variable x is called an exponential random variable with parameter lambda greater than 0 if its probability density function is given by f of x is nothing but equal to lambda e to the power minus lambda x when x is greater than 0 and 0 whenever x is less than 0. So, a random variable x is said to follow exponential distribution with parameter lambda greater than 0. So, here also like other distribution we discussed, here also one parameter, it is lambda greater than 0, it is a real number. If so, it is a continuous distribution. So, we will represent this we represent this distribution with probability density function if the probability density function PDF is given by f of x, this is equal to lambda e to the power of minus lambda x whenever x is greater than 0, less than infinity and 0 otherwise. So, usually if you draw this curve, probability density curve, so for different values of lambda you will see that. So, this is x and this is f x x, this looks like decreasing. So, now how we can find the cumulative distribution function? The cumulative distribution function of So, it is called, we abbreviate with CDF of x is given by f of x, this is equal to. So, how we define? So, you can remember that this is nothing but probability x less than equal to x. So, it is defined by minus infinity to x f x t dt. Now, whenever you are integrating, see it is, you can see that this is always taking a positive number, it is density is non-zero. So, that is why the area under the curve when x is less than 0, this will be 0. So, this is equal to 0 whenever x is less than 0, less than infinity. Now, whenever x is greater than 0, or you can say greater than equal to 0, less than infinity, this will be nothing but f x x will be for x is greater than 0. So, actually equal to 0, it will be 0. So, both the cases we will see that. So, that is why you can make here equality, it is inequality like that. So, f x x is nothing but probability x less than equal to x, which is nothing but minus infinity to x. So, f x t is defined by lambda. So, it is actually this, basically this is the definition dt, but it is non-zero when it is 0. So, 0 to x, and then f x t is nothing but lambda e to the power of minus lambda t dt. So, this is equal to how we can find that. So, e to the power, so if we lambda is a constant, so lambda, then if you do the integration minus lambda t by minus lambda. So, then if you do, so then this lambda cancelled here. So, this is minus is there. So, this is nothing but at x it is to the power minus lambda x, at 0 this is e to the power of minus 0 1. So, it will be e to the power of minus lambda x. So, it will be 1 minus e to the power of lambda x.